Good afternoon and greetings from the sunny Golan Heights. My name is Nativ Rotbart and I would like to describe my PhD project regarding the long and short-term impact of compost application on organic carbon and nitrogen pools. Both my supervisors were Dr. Asher Bartal and Dr. Adi Oren of the Israeli Agriculture Research Organization. And we shared this work with these fine people, Yotam Gueta, Shlomit Medina, Dr. Yael Laor, Professor Michael Aviv, Dr. Uri Remiyahu, Dr. Michael Borisover, and these were my colleagues. Our research motivation, compost application increases soil organic matter content and is considered particularly beneficial in arid agrosystems, which are often impoverished in soil organic matter. However, there is a gap in information regarding the long and short-term dynamics of soil organic carbon and nitrogen pools following the compost application. The depletion of soil organic matter is a global phenomenon which affects us all, and it's relevant to us all. And the organic management tends to counteract the depletion of soil organic matter using practices that enriches the soil organic matter pools in the soil. Our hypothesis that compost application is increasing the soil fertility, both via the soil organic matter and increasing the nutrients levels. This increase depends both on dose and the duration of the compost application. The carbon and nitrogen dynamics reflects the short-term influence of application on nutrient availability. Our general objective was that to characterize the effect of organic versus conventional fertilization management on the short and long-term dynamics of soil nitrogen pools in the soil in an arid area. As you can see, synthetic fertilizers supply nutrients to the plant soil. Organic fertilizer, on the other hand, supply the nutrients to the soil microbiome and by that feeds the plant and the soil ecosystem. Therefore, we count on this ecosystem to contribute to the plant itself in the proceeding. Our objectives were to explore the compost application rates on long-term accumulation of total nitrogen and organic carbon, and on secondly on the short-term dynamics of nitrogen and carbon pools. The experimental platform was a long-term field experiment conducted in Gilat in the northern Negev, which is in the south of Israel, compared to the application of cattle manure-based compost at rates of 20, 40, and 60 cubic meter per hectare per year. With conventional and compared to conventional management fertilization, which was applied with urea with 20 cubic meter per hectare per year nitrogen. Discussing the long-term effect of fertilization management. As you can see here, we have a graph that describes the total organic carbon and total nitrogen in Gilat soils. These values were obtained by averaging the measured values that were affected the long-term impact of the experiment. And you can see on the x-axis, you have the compost dose in cubic meter per hectare per year. On the y-axis, you have TOC in gram per kilogram. On the secondary y-axis, you have total nitrogen in milligram per kilogram. As you can see, compost enriches the the soil with organic matter, both carbon and nitrogen, depending on the load during the years of this long-term experiment. When looking at the seasonal dynamics, you can see, looking at seasonal dynamics, you can see the examination of the effect of fertilization and agricultural growth on the indices examined throughout the season. We did it before the compost application. We analyzed the soil 1 week after compost application, 2 weeks, 3 weeks, and 4 weeks after the compost application, and during the season, the growing season and the crops, and even afterwards in the fallow. Describing the nitrogen availability, here we can see both graphs according to time, to dates. On the lower graph, you can see the microbial biome as nitrogen, and confronted with the total nitrogen dissolved, total dissolved inorganic nitrogen. Both pools, the inorganic nitrogen pool represents the much more easy for reach for the plants, while we can see how both pools affecting each other. The organic residues from previous seasons, with the raining in the autumn. Here, as you can see, in January 2016, this period of time with the raining season and the leftovers from the fallow showed that we have it demonstrates that we have increase in both in microbial biomass and nitrogen, and a decrease in total dissolved inorganic nitrogen. Therefore, we have some sort of mineralization. As you can see, we have the total soluble inorganic nitrogen confronted with the microbial nitrogen in the soil. And you can see that there is immobilization and leaching after at the beginning of the rainy season. Therefore, we can see this decrease in total soluble inorganic nitrogen, and increase in the microbial, increase in microbial biomass nitrogen. Going further to the temporal dynamics of cold versus hot water extractable organic carbon pools. As you can see, the x-axis is still time in dates. The lower graph is in hot water dissolved organic carbon, which was sequential to the cold water extraction, using hot water at 80 degrees Celsius extracted. On the top graph, you can see the DOC in milligram per kilogram, and for all 4 treatments of according to the compost load. As you can see, that the compost packets hierarchies and the dynamic process post compost application, as you can see afterwards, application and rain events, you can see how it's decreasing the dissolved organic carbon, which shows us which changes according to the seasons. On the other hand, on the hot water dissolved organic carbon, which is a significant fraction of organic matter, it's about 2 to 3 times than of the DOC pool. It shows moderate fluctuations, and it does controlled by the long-term application of compost, which shows us how the hierarchy of between the treatments is packing. When we try to characterize the water extractable soil organic matter, which mean we we quantified the concentration of aromatic components using absorbance at 54 nanometers. We did it both for the cold extracted solution and for the hot water extracted. And we can see that there is an increase in the concentration of aromatic components in the extracts, both cold and hot, but only with the application of compost. Only there we can see this increase. The seasonal fluctuations are once more smaller in the hot than the cold extract, which is in line with the DOC trends that we showed previously. Looking further, we try to characterize the water extractable soil organic matter using that aromaticity. That means we use the SUVA at 254 nanometers, which means we calculate it according to the dissolved organic carbon concentrations. And that can lead us both in hot water and in cold water. That leads us to the notion that a significant fraction of the organic matter that it is affected by the long-term application of compost. A possible explanation to this result that aromatic constitute in compost contribute to long-term stabilization of soil organic matter. It's a possible explanation, but we do see, because the SUVA applies for aromatic matter, and it does show us a trend of increasing aromatic substance. To conclude, both the total organic carbon, total nitrogen, and hot water dissolved organic carbon pools, which are all less sensitive pools, increase with the long-term dose of compost application, with relatively low fluctuations with time between application events, and we recommend these procedures for monitoring long-term effects of compost application. On the other hand, when looking at dissolved and microbial carbon and nitrogen pools, we saw that they are sensitive to fertilization management at the short term, and they could contribute more to compost to soil nutritional potential in the short term. I would like to thank to all of our colleagues and to all of you, and both to Volcani Center for letting me enjoy this research. Thank you very much.